Good morning, this is your Stats Sensei, Mr. Spensei, and this is a exit ticket and it's based on the warm-up scenario. Hey, bro, chill out. So psychologists interested in the relationship between meditation and health connected a study with a random sample of 68 married men. That's important. I'm going to note that down. So we have 68 married men over the age of 75. And by the way, they told us the random sample. So because I have a random sample, that tells me I'm going to have to do the N is less than 10%. And they practiced daily meditation. All right. A separate random sample. Oh, so we have two random samples of 74. So sample size 74. Men over the age of 75 who also retired but did not practice. So they're not practicing meditation. So no meditation for them. The sample is found that 30 of those who practiced daily meditation, it was found 36 were in good health. And then of the group who did not practice it, 35 were in good health. So 36 versus 35. 36, those were the ones who practiced, and 35 were the group that did not. More than 500,000 men practice daily meditation, and more than 2 million do not practice it. So it looks like we have a couple populations there. So this is the practicing, 500,000 practicing, and 2 million did not. That's our populations. So I'm going to go ahead and put a couple things down. So of the group practicing meditation, we said that there were 68. And for those not, there were 74. Of those who were practicing, 36 were in good health. And over here, 35 were in good health. So while we're here, we might as well figure out what our p hats are. So 36 over 68. 36 divided by 68 gives me about 53%, so 0.5294. And over here, it's going to be a little less than 50%. We have 35 divided by 74, and sure enough, we have about 47.3%. So 0.4729, and I got that by going 35 divided by 74. So they said create a 96% confidence interval. So that tells me our confidence size to estimate the difference in proportion. Since we know it's 96%, we might as well go ahead and mark that down. We'll use that information later. So we need to do our conditions. Well, the very first condition was random sample, and they told us it was. They said we had a random sample, and it happened to be of size 68, and that was given. The next one was a random sample of size 74, and that was also given. We have two independent groups. And that was given. Over here, that's going to also follow two independent groups, because if we have it for one and we have two groups, they're both independent. So two independent groups. All right, now we need to check the N is less than 10%. So in this case, N equals 68. 68 times 10 is 680. And that's less than 500,000. So that's definitely less than 10%. So that's good to go. The next one, N is 74. 74 times 10 is 740. And that's certainly less than 1 million or less than 2 million. So that's good to go. So we're fine there. Now we need to check to make sure that our sample sizes are large enough to use the normal approximation. Now remember, if it's a hypothesis test, it's N p hat C, but here we're going to have to use N1 p hat 1 and N1 times 1 minus p hat 1. Over here, it'll be N2 times p hat 2 and N2 times 1 minus p hat 2. So N1 would be 68 times 0.5294. So 68 times 0.5294. And we know that that equals about 36. And then it's going to be 68 times 1 minus 0.5294. So let's check those out real quickly. So 68 times 0.5294. There's my 36. And 68 parentheses 1 minus 0.5294 is about 32. So both of those are greater than or equal to 10. Very important that you make the comparison. If you just put the numbers, you're not going to get credit. So then we have to go over here and N2, which is 74 times 0.4729. And that should equal 35. And this is going to be 74 times 1 minus 0.4729. So let's find out what those are. So 74 parenthesis 0.4729 is about 35, which is what we thought. And then 74 parenthesis 1 minus 0.4729 should be about 39, I think. Yeah, about 39. And both of those are also greater than 10. So it looks like all conditions are met. Normality's met here, and we've met all the other conditions. Our formula is going to be p hat 1 minus p hat 2 plus or minus z star. And then it's p hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. All right, we need to go ahead and calculate z star. Well, z star is going to be going to the inverse norm. And the first thing it's going to ask us for is the area, which is 1 minus 0.96 divided by 2. And if your calculator does left, center, or right, you're going to need to use left. So second vars, inverse norm, parenthesis 1 minus 0.96, close parenthesis, divided by 2. Z-score, so mean of 0, standard deviation of 1. Left, we're going to get a negative value, but we're positive people, so we're going to make it positive. So 2.0537. All right. My experience is I don't have enough room for this, so I'm going to round this. I'm going to call this 47%, or excuse me, I'm going to call this 53%, even though it's not. And here I'm going to use 47%. I know that it's not exact, but I need to round to make things fit. So this is going to be 0.53 minus 0.47 plus or minus 2.0537. 2.0537, and it's 0.53 times 1 minus 0.53 over sample size of 68 plus 0.47 times 1 minus 0.47 over the sample size of 74. So let's go ahead and run this thing, and we're going to go to stat test all the way down to 2 proportion z interval, which happens to be at letter B. And we have 36 and 68, 35 and 74. And we need to change that confidence level to 96%. And there's our 53% and our 47%. Those were our p hats. And we end up getting a negative 0.1158. So about a negative 11%, negative 0.1158, all the way up to a positive 0.2286. All right, so zero is contained in it. So this shows that there really does not, we cannot say statistically that there is a statistical difference. Yeah, there is some difference, but it could have happened by random chance alone. We can't say it's statistically different because zero is contained. All right, appreciate you watching and I hope to see you on the next one. Thank you.